Hello, my lovely geometric physics kids. Say this is just a new thing I wanted to try out to see how well you guys liked it. So hopefully right now you're watching this video and on the right side of your screen you also have a questionnaire. So our goal then is just basically watch the video. I'm going to work through this worksheet. So I have worksheet 3 up for you. And from there, I'm going to have the questionnaire. You're going to fill out, tell me, answer the questions basically. What did you like? What did you not like? And just give me some feedback, okay? So I'm going to turn the camera off for now. And I'll be back in 1 second. All right, so the video's gone now. So let's go ahead and get started with how to do this worksheet 3. So each one of these problems, I left you space just so that you can have some room to work. All right, it doesn't mean the problems are going to take that long. I just wanted to make sure we were able to draw a picture of everything we're doing as we are going through the worksheet. So let's see, our first one. So if we read our problem, it tells us that a pilot is dropping a bottle out of an airplane. And remember, it's a moving airplane. All right, the airplane's moving. It's recovered by a surprised native who thinks it's a message from the gods. If the plane from which the bottle was dropped was flying a height of 500 meters per second and lands 400 meters horizontally, we want to know, our goal, how fast was our plane moving? So first thing we always want to start with is a picture. So if we look at this as our plane was up in the air, and it tells us it was up in the air, so if I look, height of 500 feet. So I know over here, meters, not feet, 500 meters up in the air was my airplane. It tells me that the bottle was dropped from that initial point. It landed 400 meters, notice the word horizontally, so then our 400 meters is going to go down here at the bottom. So our projectile is going to start up here at 500 meters, and he's going to slowly arc its way down and land 400 meters horizontally from where it started. So our first goal, anytime we know how high something is, we can find out the time that it takes to fall. So our first step, we'll put some steps down. We want to find time to fall. So that's what we're going to do first. We're going to use our delta x in the y direction is 500. We know that it's going to accelerate down to the ground at 9.8 meters per second. And we're trying to find time. We also know our velocity initial in the y direction. So we know that because the plane, so as our plane is flying through the air, it's flying flat. So that means all of our velocity is in the x direction. So we have nothing left, essentially, for the y. So our time to fall. So we're going to do our delta x equals 1/2 at squared plus v initial times time. Alrighty, in this case, we're plugging in. We have 500. The 1/2, I got 9.8. I don't know my time, so I got times squared. But then my second term is 0 because my initial velocity in the y is a 0. So to figure this out then, this is 4.9 t squared. Alright, so we do this, divide by our 4.9, and to get rid of our squared, we got to take the square root of that thing. So we get a time for this thing to fall of 10.1 seconds. So that's our time. So 10.1 seconds. So let's see, that was our time to fall. Now from there, we can figure out how fast, remember that was our goal, how fast the plane was flying. Notice what we said before, that our velocity, all of it's going in the x direction. So I have things that I know in the x now. So velocity in the x, well, I don't know, but I can solve for it. I know my delta x, my distance, in the x direction. That's 400. And I know a time of how long it's actually going to fall. So our next equation we're going to find, or our step 2, is use our equation, velocity x times time equals our delta x in the x direction. Remember, we want to make sure all of our variables we're using match up with the same letter. So all of these are x's. So we're going to take our 400, we're going to divide by 10.1 to get our velocity in the x direction, which in this case is our answer. So 400 divided by 10.1. So our answer then for how fast was the plane going is 39.6 meters per second. All right, so let's try one more, and I'll have you guys do the other two then in class. Yeah, that'll work. Let's see, which other one? So you know what I'm going to do actually? I'm going to go through, and why don't we draw the picture for each one and sort of use the steps that we did here in this problem to sort of guide us through 2, 3, and 4. So what I'm going to do, I'll just draw the pictures, and then in class tomorrow, this will be what you guys are going to be working through. So you'll want to have, of course, yes, the first problem done, and all the pictures drawn for 2, 3, and 4. So let's start with number 2. It says, suppose that an airplane flying at 60 meters per second at a height of 300. So I'm just going to underline some of the numbers that we have. So height of 300. We want to know how far something goes when it hits the ground. So we have our same or very similar picture. So we know that this object is 300 meters above the ground. It gives me this time my velocity. And again, this is velocity in the x direction because of the fact that my plane is not diving down to the ground, it's not zooming up in the air, it's flying flat. So our flat motion is our x axis. So this object is going to go down some kind of curve, and it's going to hit the ground. This is the part now that we're trying to solve for. We want to know how far does it go from the release point. So that's our distance, our far does it go from our release point. So very similar steps to what we did up here. So our first goal of the problem, same as we did before, time to fall. Then we're going to use our time and plug it into the same exact equation. So hopefully that helps you in class tomorrow. Alrighty, number 3, drawing our picture. So we have a ball that is horizontal with a velocity of 3 meters per second, strikes the water 4.5 meters away. We want to know how high above the water is the quarry wall. So again, we have a wall that is up some height, which we don't know. We want to solve for our delta x in the y direction. We do know that our velocity, again, notice it's horizontal. So all of this velocity is going to be going out horizontally. Again, my object is going to go down in some kind of arc form, hit the ground, and it tells me then it hits the ground 4.5 meters away from where it started at the edge of the quarry. So we want to find out how high above the water is the wall. So there's our picture. So tomorrow in class, we'll get to figure out how to do that. All right. Number 4, Tad drops his bowling ball out of a window, and it tells us that that window is 1 meter above the ground, and they're traveling at 18 meters per second. Our first thing, we want to know how far, and it tells us horizontally, will the ball hit the ground? If the car continues to travel at the same speed, where will the car be in relation to the ball when it lands? So we have a person dropping a bowling ball out of a window. Here's our window. And it tells us that our window happens to be 1 meter above the ground. And we are going to drop a bowling ball out of the window while the car is moving. So if there's our window, all right, here's our car. And Stuart, don't laugh at me for my drawing of my car. We need headlights, don't we? Okay. That's a car. No making fun. So in this case, our car is traveling at 18 meters per second. So our picture then, I don't necessarily need my car. So our picture is the same as it has been with this initial velocity in the x direction, since my car is traveling on a flat road. It's going to be 18 meters per second. My object is going to curve down until it does hit the ground. And in this case, it wants to know what is that distance at which it's going to actually hit the ground. All right, so tomorrow in class then we have 2, 3, and 4 to sort of work through based on this first example that we were given. So now that you're done watching the video, take just a couple minutes and answer the little questionnaire on the side, or if you were doing it while watching the video, that's fine too. Just make sure that before class time, before the class starts, that you've submitted your responses, because that is your homework. You're submitting a response to the questionnaire that's on the side to let me know what you didn't get and what you did get. Okay? So I'll see you guys tomorrow. Bye-bye.